Let us learn how to solve multi-step inequalities with integers. We're going to examine the steps that we follow generally in solving multi-step inequalities, and then we're going to apply those steps with these types of examples. We always want to first isolate the variables like we do with equations, and then we solve them. And then we want to pay attention to the position of the variable and the inequality. Ideally, we want the variable on the left-hand side of the inequality, and we want the constant on the right-hand side. If they are not, we want to switch them around. When we do switch them around, we're going to have a situation where we have to switch the inequality as well. So if it's greater than, we change it to less than. If it's greater than equal to, we change to less than equal to, and vice versa. And then we'll represent the inequality on the number line. And here it says not required because sometimes you don't have to actually solve the question. Some questions may require you to represent on the number line. A lot of times doesn't. So look at our first example here. 7x plus 9 greater than 3 parentheses x minus 1. So we always have to honor PEMDAS in everything that we do when you're trying to solve equations or inequalities. So the first thing we're going to do is to distribute the 3 into x minus 1. So 7x plus 9 is greater than 3x minus 3. So now we're going to subtract 3x because we're trying to isolate the variable. So 7x minus 3x, that's 4x plus 9 greater than negative 3. So now we subtract 9 from both sides. So 4x greater than 3 plus 9 is 12. We put the negative sign. Now we divide both sides by 4. And then we have x greater than negative 3. So represent that on the number line. This is 0. This is negative 3. It's greater than, so it's an open circle. X greater than negative 3. Next question, we still have to honor PEMDAS because we have parentheses. So we have 5x greater than 24 minus 3x. So we add 3x to both sides of the equation. Add 3x. So we have 8x greater than 24. It's greater than equal to actually. So we divide both sides by 8. Divide both sides by 8. So you have x greater than equal to 3. So we represent this on the number line. We have 0 here. We have 3 is greater than equal to. So we have a closed circle greater than equal to. Next example, we have 5 minus 5x less than equal to minus 2x minus 4. So what we're going to do here is I'm going to add 2x to both sides. So we have 5 minus 3x less than equal to minus 4. Now we're going to subtract 5 from both sides. So we have minus 3x is less than equal to minus 9. Now we're dividing by negative 3. Divide by negative 3. So we have x here, and then we have 3. Because we're dividing by a negative number, we have to switch the sign so it's greater than equal to. So we have 0, then we have 3. It's going to be a closed circle. So x is greater than equal to 3. And then a final example, we have 24 minus 2x less than 6x plus 4. So I'm going to add 2x to both sides first. Add 2x. So 24 is less than 8x plus 4. Now we subtract 4 from both sides. So we have 20 is less than 8x. Now we divide both sides by 8. 20 divided by 8. Let's show some work here. we divide both by 4. We have 2, 5. So we have 5, 2. So 5 divided by 2, that's 2. 2 multiplied by 2, we have 4. We subtract it, 2, 1 over 2. I usually like to convert them to fractions because the answers with fractions are more precise than decimals. But you can. This is a simple enough decimal, but I just like to use fractions better. So we have 2.5 is less than x. So now we have to swap them. It's just the best practice I like to use. It's less confusing for the student. So we have x and then 2.5, and we're going to change the sign to greater than. So we have 0, 2.5, and so we have x is greater than, so we have an open circle, and that's it.